So if we have 3 to the power of 2x is equal to 243. Now you're accustomed to solving for x when you're dealing with equations, but you're not accustomed to these exponential equations. So if we want to work out this particular problem, alright, the first thing you need to do is ask yourself, well, if this is in the power, what can I do using my knowledge of powers to help me with making this equation something that I can work out? And the first thing that you will do whenever you're doing exponential equations, especially in math, first thing you want to do is bring all the numbers to one common base. So anybody could recall what is the base when we're talking about exponential equations, when we're talking about things with indices and stuff. What am I referring to when I say the exponent, and what am I referring to when I say the base? Whenever we talk about exponential equations, like we just said, we need to know that basic information. So you need to know what is the base. And the base in this case here, on the left hand side, the base is 3. So whenever you're working with exponential equations, it's important that you bring both sides of the equation to the same base. And we'll talk about why we're doing that in a little bit. But if I want to bring both sides of the equation to the same base, if I look at what I have here, I already have this as 3 to the 2x, but this 243. I need to bring this to the same base as what I'm seeing on the left hand side. So I need to bring it to base 3. So, anybody, what will we get if we try to bring 243 into an exponential form like this in base 3? What will we get? When you want to express numbers in index form, and especially here because it was critical to bring it to the same base, we need to be able to at least do consecutive division of this number by our desired base, alright? So 243 in terms of base 3 is 3 to the 5. Now, I've come to this point, alright? I have 3 to the 2x is equal to 3 to the 5. I have a question. 3 to the 2x is equal to 3 to the 5. What does that say to me? What does it say? Why is it 3 to the 5? Alright, for us to understand where that 3 to the power of 5 came from, you could do it one in two ways. You could double check yourself by multiplying 3 by itself 5 times, and you get 243. Or like I was showing you the other day, once you understand how to do the conversion from base 10 to any other base, you'll understand what it's doing. You are repeatedly dividing the number by the base. So I want to turn it into base 3. I divide 243 by 3. The first time, dividing 243 by 3, I'll get 81. Then this is also divisible by 3. So I'll divide it again by 3, and I'll get 27. And then I'm going to divide yet again by 3, because this is still a multiple of 3. And I'll get 9. And still, it's a multiple of 3. So I'm going to divide again. Just now. So, as I was saying, because you want to convert it to base 3, consecutively divide by that base, and that will tell you what you're raising this base to the power of, so that you will be able to get back the 243. So 3 to the power of 5, because as you can see here, we did 5 consecutive divisions. 3 to the power of 5 will give us the 243. Clears it up? Alright, great. So let's get back to this. When I say 3 to the power of 2x is equal to 3 to the 5, what does that statement tell you? What does that statement mean to you? And if I have 3 to the power of 2x is equal to 3 to the fifth, this means the two statements are equal, regardless of what they look like. So if I want to work out x, this is where that knowledge is going to come in now, with me understanding that both statements are the same. Alright, both statements are equal to the same value. So here, if my bases are the same, then that means my powers also have to be the same. Alright, and while 2x doesn't look anything like 5, we can say that, okay, x is an unknown, right? X is something that we don't know. But if the bases are the same and the two statements are the same, then by, logical reasoning there, these two things, this power of 2x and this power of 5, these powers have to be the same. So the final thing you actually need to do here to help you solve this is equate your powers, right? Equate your powers. So equate powers, and when you equate the powers, you're going to get exactly what Kyla has in the chat, which is 2x is equal to 5. And from here, doesn't that look like something you're accustomed to trying to do in maths? There you go. Just need to solve for x, and that's all there is to it. And once you can do that much, 2x, you're going to divide both sides by 2, and you're going to get that x is equal to 5/2, which you can leave as an improper fraction. You can write as a decimal. You can write as a mixed number. The answer is still going to be the same once you can convert properly, and you will get that x is 5/2, alright, or 2.5. And one of the things that I strongly suggest, if you're the type of person to always doubt yourself and you know how to work powers out, what you can do is take the value that you get for x and substitute it back into the equation. And when you substitute it back into this equation, it should work out to give you 243. Alright? And if we recheck it, we'll see for ourselves that 3 to the power of 2, where x is 5/2 now, this will simplify to being 3 to the power of 5. And 3 to the power of 5 we know is 243. So that's how we know that we got the correct answer for x. Okay? So anytime you have to do exponential equations like these, first things first, express both sides of the equation in terms of the same base. Once you can do that, in some instances you're going to have to use your laws of indices to simplify things, right? If you have to apply a law, apply it properly, and once you bring it to look like something like this, where you could just equate the powers now, and then from there you'll have a linear equation to solve for x. Now we want to work out this particular exponential equation. If I'm working on this particular exponential equation, start off the same exact way. Look at your equation, and when you compare both sides, can you identify a common base that you can bring both sides to look like? Both sides in one common base. Which base you write? 4. Alright, the fastest thing to always do, look for like the smallest number. So you could see clearly that you have base 4 here. You can try to bring the 64 to base 4, because it is possible to express 64 in terms of base 4. So that's your first challenge. Can you express 64 in terms of base 4? So let's see. What do you get when you express 64 in terms of base 4? There we go. Yeah, that's correct. 4 to the power of 3. Alright, now that we have 4 to the power of 3, we're going to substitute that into our equation. So we're replacing 64 with 4 to the power of 3. But what we need to be careful of is this. Remember, this original equation here has 64 to the power of 3p minus 2. So if I am replacing the 64 with 4 to the power of 3, I then need to remember that 64 was originally raised to the power of 3p minus 2. So that's why I'm going to raise 4 to the power of 3 to the power of 3p minus 2. Everybody follows so far? Makes sense why we do that? Alright. So always make sure you pay attention to those things, alright? Now there's another way we could waive discussion. I'm not going to go into that one, but it's something that you all can consider looking at. If we had to work with base 2 instead, because both numbers can be expressed in terms of base 2 as well. Alright? Now from here, yeah, we have the same bases, but you'll notice something. This power raised to an x power, you need to do a little simplification there. Which law are we going to apply so that we'll be able to simplify this statement and then be able to solve the equation for p? Tell me, which law would you apply here? Yeah, they want to multiply. That's the one. Alright, so the one that we're talking about is this one. If we have e to the power of x and we're raising that to the power of y, we will get a to the power of x, y. Okay, next. Applying that law here, what will I get as the power on the left-hand side? Anybody? I have to find the product of the powers. What will I get? Beautiful. 9p minus 6. Alright? We have to remember we're multiplying 3 by 3p minus 2. Alright, so what did we do? We multiplied this. And once you remember distributive law, expanding brackets business, we would be able to work that out and we would get the answer. Alright, next, what do we do from here? Now that I have both sides of the equation in terms of base 4, power's looking a little different, but what should we do now? All you have to do now is equate the powers. Alright, and that's where this equation pops out from. And then we can do, as Kyla said, rearrange, bring the like terms together. You just need to know how you get there. Okay, so always remember to equate the powers once you get to this statement. And when you do, you have fun doing your algebra, alright? If you choose to bring like terms together and you say it whatever way you want to say it, whether you want to add 6 to both sides and then simplify, or you want to say you're gonna move this across and move that across, some kind of thing, your choice. But the important thing is to remember that you simply need to equate the powers first before you do anything with the algebraic statement. Alright? So from here now, anybody wants to tell me what we'll get when we try to solve the equation to get a value of p? There we go. Nice. And if 5 plus 6 would give us, there we go. Continue. Very good. Very good. Uh-huh. There we go. And you'll get your answer. You'll get that P is equal to 11 over 7. Right? And again, you could either write 11 over 7, you can write the mixed number, you could write it as a decimal, which would end up being recurrent. Your choice, but ultimately, it still boils down to being the same exact thing. Alright? You will get the answer, and you can test it back out in your equation. So let's say I gave you all a to the power of 2x is equal to 1 over 64. How would you approach this question? A to the power of 2x is equal to 1 over 64. Alright, so I think you say the two things are kind of connected to each other, but you probably say them in the wrong order, as in, like, the 64 wouldn't be turned into a negative number, it would be to a negative power. And I think that's what you wanted to say. Yeah, right? And then you could convert it to a base 8 number. So you could either, one, bring the 64 upwards, which would indicate that you'll have to change the power to a negative number and then convert it to base 8. Or you could change it to base 8 first and then bring it up and the power will become negative. So up to you all. Like as I always say, once you know your rules, you'll be able to do absolutely anything. So let's go the way of bring the number up. So if I bring the number up, what becomes the power? Yeah, negative 1. Because 64 was to the power of 1 in the denominator. And now 64 is going to be to the power of negative 1 because we bring it up out of the denominator. From here, as Adina was saying, we're going to change the 64 to a base 8 number. So can you change 64 to a base 8 number? Nice. That's it. So we're going to change 64 to a to the power of 2. So again, just like the last one, we're going to remember to replace the number itself. We're going to put the brackets. And because it was originally 64 to the power of minus 1, we are raising a to the power of 2 to the power of minus 1. Now what do we do from here? We do have the base 8 already, but what should we do before we try to solve for x? Alright, but before we equate the powers, what we should do? Anybody think we should do anything else? Yes. Yeah, this one. So anything raised to a power that you're raising to another power, remember, multiply your power. So simplify for me using your power rule, and you get 8 to the power of 2x is equal to 8 to the power of 2 by minus 1 should give me what? There we go, negative 2. Negative 2. Alright. Now, what we're going to do here? Nice. So let's equate the powers. And what do we do? Equate the powers. What we getting? Nice. And we get that x's. Lovely. There we go. Alright. So even if you decided, same thing I will say like the last one, you could bring these numbers to be in terms of base 2, and that will give you the same answer. You could bring them to base, well, this one in particular, you could have brought base 2 first and then bring up and then equate equate your powers. Alright, so you just need to know how you want to go, right? Work with whatever is comfortable for you. So if it is easier for you to bring up this and then convert to common base and whatnot, do it that way. If you want to change everybody to a completely smaller base than leaving it in base 8, your choice. Alright, so here what we're gonna do one more, and especially because it's 923, so we're going to bring the 125 out of the denominator, brings it up, and we get a negative power. What is the negative power going to be? -1. Alright, now, here's the thing. We have 25, we have 125. 25, 125. 25, 125. Okay, how are we doing this now? Because I can't express 25 in terms of base 25, because 125 is not like 25 squared or 25 cubed or anything. So that's it. So we need to bring them, both 25 and 125, to a common base. So there we go. Yes, base 5. So if I'm expressing 25 in terms of base 5, what will I get? There we go, 5 to the power of 2. And what about 125? 5 to the power of 3. Yep. There we go. Alright, what next? So we're going to use that. 5 to the. That's it. Yeah. No doubt for that. Go ahead. Yeah, that's all there is to it. Alright, so we got 5 to the power of -3. So now we have 5 to the power of 4x is equal to 5 to the power of -3. Alright. So what will we get from here? And what we do now? Nice. And again, you could write it as a decimal if you'd like, but the answer is -3/4. Alright, and just like I was saying before, you just need to substitute it back into the original equation and you'll be able to get the answer once you know how to use your laws of indices properly, and it will tell you whether or not you've gotten the correct answer. Alright? So that's that.